Hello, this is Paul from Foresight Tech. In this video, we are going to deal with the derivative of trig functions. Let's going to see the material. And from trigonometry, everyone remember, so we learned 6 types of basic trig functions, right? And in this video, so first I will going to introduce the derivatives for all the 6 types of trig functions, and I will give you proof as well. And then I have 3 questions to work together. Let me look at the first, which is a sine function, right? That's the very basic trig functions we learned a long time ago. Here I showed you the formula. The derivative equals cosine. The derivative of sine is cosine. What does this mean? Okay, first, and the derivative exists, which means that the function is differentiable at any point, right? Differentiable, which means it's smooth. Of course, the sine function is smooth, everyone knows. And why the derivative equals cosine? We have to prove. But first, we look at this graph, okay? So we get a basic idea that the graph shows us the derivative is cosine. Excuse me. Let me look at it first. Sine function is like a wave, okay? It's on the top, and at the bottom we are going to draw the derivative function. Of course, we only can roughly draw, right? So you can explore the functions. We just pick some point and to draw the derivative. For example, at 90 degree 0, at a negative 90 degree 0, and 0 and 0. Okay, this is 0. Another at 0, see, there's a tangent line, like y equals x is 45 degree. So the slope is 1. So that's the maximum. There's 1, the negative 1, and the same. There's 1, there's a negative 1, there's 1. Okay, we have these basic points and link together. This we get a rough graph for the derivative function. What does this function look like? Everyone remember this looks like a cosine, right? Looks like a cosine, but it is not a proof, okay, definitely. So we only get the idea. Now we were going to exactly prove, okay? So how to prove? I show you here. And I have 2 methods we're going to show you, okay? So we will not take a lot of time. So look at it. The first formula, the first method we call use sum formula. Okay, so we have to use some trig identities we learned from trigonometry. Okay, so we look at the first sum formula. What does sum formula mean? Do you remember that? Okay, we have a lot of sum formula. So what the sum formula we have to use here? So let's look at first. What we are going to do, we have to use the definition, right, of the derivative. We're going to find the derivative. The derivative, if we use this notation, remember, is use h notation, right? So this delta x h, the top is delta y. Okay, sine x plus h minus sine at x. That's the definition. Okay, and now we see sine at x plus h. If someone remember, this is the sum formula for sine function. Okay, so we have 1 sum formula for sine function. So if I put here is already sine at the first x cosine at the second plus cosine at the first angle times sine at the second angle. Do you remember this? That's the formula. So we call the sum formula. Let me write down here. Of course, someone will ask this: why we will not directly put h equals 0 into the function? Yes, you are right. So we can try that first. We will plug h0. So there's sine x minus the top is sine x minus sine x, which is 0. The bottom is also 0. So what do we get? Can you see? Of course, we get this. We get 0 over 0. Which means indeterminable, right? So indeterminate form. That's why we need to do other stuff. Okay, we just said the sum formula. Let me go into write here. Remember this. We have a sum formula, right? Okay, so we already used the sum formula, and I used the red words. Sine equals this. If you break it down, the two angles into individual angles, so we have a looks a little complicated formula, but this works for us. Now what do we do? Can you see we have a sine x cosine, sine minus sine. The first term and the third term we put it together, so we can factor out the sine, right? And the left cosine h minus 1. The second term we step here. Okay, why we do this? And because we can now separate it into two fractions. Okay, this is a big fraction. We can separate it into two fractions. The first fraction is sine x times this fraction. Okay, the second, of course, cosine x times this fraction. So now what do we have? We have two terms added together to find the limit. Do you know what kind of law we can use? Of course, it's sum law, right? So we have sum law of the limit. We can separate it into two limits, and for each limit, can you see the first? And the sine x has nothing to do with h. You can see sine x is just a constant number, so we can factor out the sine x out of the limit. Do you remember what the name? We call it a constant multiple rule, right? Or you can see if we put those together, the second term cosine is also like a constant number. Okay, and they also can factor out. So this is basically the limit law we use. Let me put here. This is the limit law we use. If someone remember the limit laws, if we put these two laws together, we can see sine x is a constant number, cosine x is a constant number. Okay, that's we also call the linear property, right? Linear property we learned before. So after we figured out what do we have now? We have this limit. If someone remember the last video we did, which is the we're going to find the trig limit, right? This we call it the trigonometric limit. So we have a formula. So this is what? This is 0. This is not called a formula. Okay, we do have a formula for the second term. Can you see this? And the formula tells us this is 1, right? Definitely this is 1, no problem. And for the first, this red term, okay, it's not a formula, we cannot say, but we did the example in the last video. Okay, the last example, if you're going to go over, you can find the result is 0, right? Okay, so now we do have the first term goes to 0, the second term goes to cosine. Now we have the result is what? Of course, there's a cosine. Okay, so this is the first, and I said we just have the let me write it here. I refer if someone you're going to see why the first is 0, and you can see this video and the trig limit. Okay, all this is from trig limits. You can find the detailed information in the video 3.3.1. Okay, so now here is the proof. That's exactly the proof. Can we see? Go back to go over. Okay, so all we need is the first step to sum formula, expand. Okay, and then do some calculation. And this proof give us what? We find the derivative, which means sine x is differentiable. That's normal, right? Which means sine function, the curve is very smooth. We know sine is very smooth. Okay. This is only the method 1. So I have another method for you. So you will see the second method will be much easier than this method. Okay. So here, so you can see it's here. How to do? So we have to use another formula. Okay. So we call the sum two product formula or sum two product identity. You learned from trigonometry. Okay. I will show you what the formula. Okay, so first, let me go to write the definition. No problem, right? The second step now, we will not expand this one big term, but we use sum to product formula to combine these two difference terms together. Okay, one term minus another term. You can say the one term plus the negative another term is sum. We can change this sum to product. Use the sum to product formula. Can you see what I wrote here is already in the form of product, right? Okay, the product is easier than the sum in these questions. Which formula I used? Let me write it down for you so you can refer. Or if someone you forget it, you can go Google. Okay, you definitely find. So let me write a little bit small. Okay, can you see? And this formula, let me show you, is like this. Okay, I should use sine alpha minus sine beta. This is the formula I used in these questions. Okay, it's 2 times cosine at alpha plus beta over 2. Okay, and then is times sine alpha minus beta over 2. Can you see? It's a little bit small, but I hope you can see it. Okay, in our questions, what is alpha? The first angle, which is x plus h. What is beta? Is x. Okay, can you see the formula? So the first is cosine at what? At the average of two angles. The average of two angles, x plus h plus x over 2, of course, is x plus h over 2. We get it, right? And the times sine. And what the second? The second is the half of difference. Usually we say half of difference. Okay, the difference x plus h minus x, we get h, right? Half of h, which is h over 2. Okay, you can see we just use this formula, we get the results. Then now, okay, so we're going to here. This step is easy. We almost, okay, and the 2 is on the top. Okay, if we divide it by 2, both numerator and denominator, 2 will go to the bottom, h over 2. Okay, and then we separate it into two limit. Can you see? The first cosine, we goes to one limit. The second sine over h, like this big term, we're going to another limit. You remember what the law? Of course, this is a product law, right? So let me show you. We go back. So what do we have here? So all we need to use is the limit law. Okay, we just use the product law. We have two limit. Of course, what is the first? One by one. Look at the first term. Cosine is continuous, we know, right? So we can directly substitute. H is 0, x plus 0 is x. Therefore, the first is going to cosine. You know, the first term we use the continuity, right? So we know is a cosine. The second term, can we see the second term? If you substitute the h over 2 is theta. That's sin theta over theta. Take limits as theta approaches 0. Do you remember the formula? Yeah, so we do. The last video we did, right? This approaches 1. Okay, and therefore why this is cosine x times 1 equals cosine. Can you see it? The same results we get, right? This is much simpler than before. Okay, if you like this proof, this is much simple. Okay, so now we have the formula for sine. The whatever sine, take derivative goes to cosine, right? Now we go another. The second type of trig function is cosine. How about the cosine take derivative? Okay, you can see cosine is very similar as a sine, right? And it's also smooth functions. The curve is very smooth, so we can do the similar way. Okay, and if someone you like the first way and they use the sum formula, you also can do. But here I use the sum to product formula, which is the second method we use to find the derivative for sine. Okay, now I will easily define the derivative for cosine, which is negative sine x. And you know how. Okay, so I will show you here. So the first, as the sum to product, of course we have 4 types of sum to product formula. I think you learned. Okay, which one we use I will write here later. So but first, let me look at it. the first step is the definition, right? We are going to find the derivative, which is the limit, okay, delta y over delta x. And now we're going to put these two sum together into product. Let me write down the formula. I will get this one to write to you. Okay, so I think you can see. We're going to use this formula. So this time I use this. I use cosine alpha minus cosine beta. Why? Can you see? Because we have cosine angle minus cosine at another angle, right? Which is this. This equals what? This equals 1 negative 2, okay, times sine at the average, okay, this is the average, times sine, another sine at half of the distance. Very similar as the last one we used. Okay, so now we're going to use this formula. Okay, what is alpha? The first angle, which is x plus h. What is beta? The second angle, which is x. Okay, I plug into this formula. I get a negative 2 times sine the average, which means x plus h plus x over 2. Of course, we get x plus h over 2 times sine. Okay, the second is what? Is half of the difference. Okay, x plus h minus x, we get h over 2. See, this is half of the distance. Okay, of course, now we have the formula. It's easy. It's very similar as the first one. This negative are plug out, so put here. So we have 2. And these 2 are put to the bottom, which is h over 2, right? And then we put the sine and the h these together. And the first sine is one term. We separate it into two limits. Can you see? The first limit times the second limit is exactly similar with the first proof. Let me show now. All we need now is what? Is just okay, so I get this. It's just the limit law, you know. We just use the limit law. Okay, product law. And now you get it. The first is continuous, right? Goes to sine. The second is a formula, goes to 1. And then the result goes to negative sine x. Can you see? That's the proof. Super easy, right? If you use this method. Okay, so now you get the second formula, which is a cosine. Take a derivative goes to negative sine. Don't miss this negative, okay? Let me go into the third type of trig function we learned before. What the third type is tangent, okay? What's tangent mean? Okay, if you remember, tangent is sine over cosine. So all we need is just use the quotient rule, okay, as we're going to see. If someone remember the graph of tangent, of course on the domain is very smooth, right? So derivative exists. So here we should how to find the derivative. The derivative is secant square. Secant square. All we need is just use the quotient rule. What does it mean? So first tangent x are wrote into sine x over cosine x. That's the definition, right? Or someone you say is the quotient identity. Yes, it's the same. Okay. Now we do have a quotient. Going to take a derivative. Take a derivative to quotient, which is the quotient rule, right? Okay. It is the quotient rule of limit. Let me write here. It's just the quotient rule of limit. If someone remember this, we are going to practice again. Can you see what is the derivative of quotient? So the bottom square. Can you see the bottom is cosine square, right? What is the top? The top is very similar as the product rule. Okay, the top take a derivative, the bottom minus. Keep in mind here is minus. The first term, which is the top, times the derivative of the bottom. Okay, do you remember the first take a derivative, the second take a derivative? Okay, now all we need is use the derivative formula for sine? Someone remember, right? Do you remember what the derivative of sine? Cosine. What is the derivative of cosine? Don't forget the negative, which is a negative sine. We just got it, right? We just got it. Now we just simplify cosine square, put here, negative goes to positive, so plus sine square. If someone you remember cosine square plus sine square is 1. So what the name? We call the Pythagorean, right? Okay, if someone remember this, is just a Pythagorean, okay? Pythagorean identity, which is 1. And then 1 over cosine square. Do you remember reciprocal of cosine is secant, right? Okay, if you remember, it's just here is a reciprocal. Okay, reciprocal identity you learned from trigonometry. Okay, so here is the result. Is the one I showed you at the beginning? Yes. Okay, and it's super easy to do. All we need is use the quotient rule of limit. No, not of limit. Sorry, I think I made a mistake. So here is the quotient rule of derivative. Okay, so let me write down here. Okay, of derivative. Okay, differentiation. Derivative. Okay, I wrote it wrong. Okay, so now here is the third one, right? So we move to the fourth one. Okay, you see the fourth trig function is a cotangent. Now we are going to deal with the cotangent. You can see I did not show you here. Okay, so why? Because this is very similar as what you get from the tangent. Okay, so I leave this proof for you. What is the derivative of cotangent? So the formula here is the derivative of the cotangent function is negative cosecant square. Okay, so it is super easy. Okay, it's not a challenge. So I know you can get it. Okay, it's just a piece of cake for you. Okay, all you need to do is just refer to the proof. So for tangent, so can you compare tangent take a derivative is secant square? Cotangent take a derivative is a negative cosecant square. The only difference is secant go to cosecant. The major one is we have a negative. Okay, so you just refer to this proof. All we need to do is what? Write it into quotient, right? So up here, you can either use this. You can use the quotient. Cosine over sine, use the quotient rule of derivative. You can get the results. Or you can use this reciprocal. Okay, it's the same, of course, use the quotient of rule, because now we know what is the derivative for tangent, right? You either use this or the first. Of course, finally, you have to know what the definition for cosecant. Cosecant is the reciprocal of sine. Okay, you put all these together, definitely we can find. It's exactly similar. Okay, with what we proved here. So I'll leave this to you. Now we have the last two functions to go and do. How about this? This is a secant. Okay, how do you find the derivative of the secant function? Can you see the results? Is secant times tangent. Looks much more complicated than before, right? Okay, but the way is still simple, so don't worry. How do you do? All we need to do is just use a quotient. We use the definition for what is a secant, which is the reciprocal of cosine, right? If someone remember the name, or sometimes we say is the reciprocal identity. Okay, the reciprocal identity. And then you can see this is one is a function, cosine is a function, that's a quotient. We're going to find the derivative of a quotient. How? We use the quotient rule, right? So let me still write it here. Is all we need is the quotient, the quotient rule of derivative. Okay, of derivative. You remember this? We are going to practice again. So first is the denominator square, right? Square of the denominator, cosine square. Then the top is still the similar. The first take a divider, 1 take a divider times the bottom, minus, right, the top times the derivative of the bottom. Okay, 1 by 1. 1 take a divider. Constant function has 0 as the divider, right? Okay, this is the result we put here. Cosine x, we already got it right at the beginning. So which is a negative sine x. Now we plug in. The first disappear. The second negative goes to positive. So what do we get? The top we have a sine x. Okay, the bottom we have a cosine square. You already get it. However, we simplify a little bit to get it what it is the same as the formula. Okay, so the denominator, we just now what are we going to do? We just separate it into two fractions. Okay, the first fraction is 1 over cosine. The second is sine over cosine. Can you see the bottom is cosine square? The top is sine x, right? This is times. Of course, 1 out of cosine is secant. Sine over cosine is tangent. Can you see? It's exactly the same. Okay, the last step, what we use is the reciprocal identity and the quotient identity, right? Or simply I say what we do is use trig identities. Okay, we use the basic trig identities, we get the results. Okay, so this is the fifth formulas we get. We have the last. I also leave this last for you. Is the same. Is I think is just a piece of cake for you. You know, everyone. So not a challenge. So all we need to do is just follow the way we did for secant. Okay. We compare a little bit. Secant derivative of secant is secant times tangent. See, what is the derivative for cosecant? Is negative. We always have a negative. Okay, cosecant x times cotangent x. Okay, of course, if you follow the way, all you need is root cosecant into the reciprocal, which is 1 out of sine, and then take a derivative is the quotient rule of derivative, right? So you have to deal with the quotient again. So that's all the formulas. What I'm going to do now is just put everything together. So I hope you get all the ideas. I put this together. This is important for us, okay, to memorize all the formulas. Okay, all we need to do, the basic, I'll just show you a tips. All we need to, we have 6 types, right? All we need to do is just memorize the last 3 types, which means what? Memorize sine. Derivative of sine is cosine. Memorize the derivative of tangent is secant square. Memorize the derivative of secant is secant times tangent. And then the right 3 term, okay, it's easy to see the pattern. What is the pattern? Cosine, the cofunction of sine. Cotangent is the cofunction of tangent. Cosecant is the reciprocal, the cofunction of secant, right? And then we take a derivative. Can you see? Derivative is just goes to the derivative of the reciprocal, the cofunction. What is the cofunction of cosine? Which is sine. Which is the cofunction of secant? Is cosecant. What is the cofunction of secant? Cosecant. Cofunction of tangent, cotangent. Of course, only one difference you can see is the negative. That's what I highlighted here. All you need to pay attention is this negative, okay? Keep in mind that this is the major one. It's very easy to make a mistake. Okay, I hope you get the pattern. Okay, use the cofunction to see the formula. To memorize the formula is a very easy way. Okay, so you can memorize it all. If you know the left 3, then you know the right 3. Okay, so what we left, and I will have 3 questions. Let's practice together. Okay, so how to use this formula. All you need is just a simple memorize. Okay, let me going to see the first here. What does this mean? We see sine, right? if you're going to take a derivative, definitely you need to use the derivative of sine. The derivative of a sine is cosine. If someone remember, that's all we need. So first, of course, what do we need to do? So let me see. I will going to erase this. So I will get, wait. Okay, so I have to do something first. What? I have to use the product rule, right? Because what? Because we have a product of the function. So let me write here. The first step, I have to use the product rule, okay, of derivative. Let me going to use the product rule, which is this. F take a derivative equals. Remember, so here the first e raised to the x is the first function f. Sine x is the second function gx or g. So how to use the product rule? Okay, I think you remember this. The first take a derivative, which is ex. We're going to take a derivative, right? Times the second plus the first put here times the second function take a derivative. See, can you see? This is the product rule, and we said the pattern is easy to see. Still the same order, and the first term is the first take a derivative. The second term is the second term take a derivative. Okay. Now all we need to do, we find the derivative of e raised to the x power, which means the derivative of a natural exponential function. Do you remember what the derivative? Of course, is the self, right? And the second term is what the derivative of sine, which is cosine. That's all we need. Let me put it here. So we get the first ex, right? We times sine x, and then we plus the second. What is the derivative for sine is cosine. Let me use another color. Remind you this is the formula we learned today. Okay. So if you like, you can stop it here, but I suggest you to factor the e raised to the x power together. Why? Because we can get a little simple. See, e raised to the x power, put the parentheses. So what we left, if we factor the common factor out, we have a sine x left, and then we have a cosine x left, parentheses. Okay, so if we're going to here is much better. Okay, this is a little simple. Very easy to use, right? So let me look at another questions. We have two more questions to practice for these formulas. Okay, how about this? We cannot directly go into derivative, take a derivative to cosine, take a derivative to tangent. Now, what we need to do, the first step, we have to do this. Use linear property. Okay, all you can say is the differentiation rule, right? The differentiation rule. So we simply say is the linear property. If you see this is the term fx, 1 times fx, and 2 times gx, right? That's a linear combination of the two functions. Okay, and what do? So you say is a linear property. The derivative goes to the first term, derivative goes to the second term. Forget about it. Okay, the coefficient, linear property. Remember this. So we're going to use the linear property, see what kind of results we can get. So now we have the derivative of f is 1 times the first derivative. Let me copy the first function, take a derivative, plus the second 2 does not matter, right? And times tangent x parentheses, take a derivative. See, that's the linear property. Okay, so of course the first term, what do we need to do? Product, right? Because we have 1 term, 2 term. Okay, product. Let me write here. This is a product rule. We have to use the product rule. If I use the product rule, what do I get? The first term, take a derivative, times the second term, plus the first term times the second term derivative, right? This is the product rule. And then 2 times what? What is the formula for the derivative of tangent? Do you remember what is the derivative of tangent? We just get it is square. What kind of a square? Secant square, right? Okay, let me show you here. Secant square at x. Okay, so all we need to do now is just do a simple step. So what is the first? Let me put it here. That's power, right? X take a derivative is 1, so I ignore the 1 cosine x. What is the derivative of cosine? For some, if you remember, is a negative. Don't miss the negative. Okay, so negative sine x times x. The negative I put it to the beginning, which means minus, right? Plus the negative is minus. So I still wrote this order. X times sine x. Okay, so this is the formula that we used. I just copied the last. The last is 2 times secant square x. And we cannot simplify it already. Okay, so we stop at here. That's the second questions. One more, the last questions. Can you see these questions? What do we need to do now? Of course, the first step you see that's a fraction. Quotient, right? Okay, so we have to do quotient rule, whatever. We have to use the quotient rule of derivative first, okay? And after we use, and then we need to deal with the derivative of cotangent. See if you remember what is the derivative of cotangent. So I will going to ask you later. Let me write the quotient rule first. So we have the derivative should be equal this. It's a very long, right? Okay, let me write here. The denominator square, which is ex square. The top is the first take derivative. Okay, do you remember the formula? The first cotangent x take a derivative times the bottom, right? And then I just use another two. Okay, remember this is negative. Don't forget. And the top function times what? The bottom function take a derivative. Do you remember this? That's the quotient rule. Now we do step. Okay, all we need is just a prolog. What do we get? And I will put this. Wait. So the denominator I can write in this way: ex square still. The top. So what is the derivative of cotangent? Remember, cotangent is a cofunction of tangent. Okay, we always have a negative, right? If you remember, is negative. Okay, what is the function cosecant square at x? Do you remember? Because tangent take a derivative goes to secant square. So cotangent goes to cosecant, but we have a negative. Okay, so that's the way we have to memorize that formula. And now I copy others. That's minus cotangent x times okay. The derivative of a natural exponential function is itself. See, almost. Of course, we not stop it here. We're going to simplify a little. How to simplify? So look at e raised to the x power. E raised to the x power. What we can do? We can factor, right? I will going to do this step. We're going to simplify something. E raised to the x power square. If I factor, we have a negative and a negative. It's better I factor the negative one out. So what do we have? Let me use this. So which is negative e raised to the x power. This is the common factor. I factored out. Okay, so what do we left? So this is a cosecant square, right? And plus cotangent x. Can you see this step? This is just factored out, right? It's simple. We just factored out. Then now what we can do? We can simplify. We can cut the common factor, e raised to the x power, e raised to the x power, right? We cut 1. So what do we left? So now we get the results. Let me write the results is like this way, okay? The bottom now is e raised to the x power. The top is negative still there, okay? It's negative. Parenthesis cosecant square x plus cotangent x parenthesis. Okay, so I just stop here. If someone you want to continue to simplify, you can do a little bit, okay? You can use the reciprocal and the cotangent change to sine and cosine. You can get a little bit simpler than this, but that's not the major one, okay? I just stop at here. And this is all we learned today from this topic about the derivative of trig functions. And I summarized all the 6 type of functions for you. Don't forget it. Try your best to memorize it, okay? It will benefit you in the future. That's all. Thank you, everyone. If you have any question about this topic, so please leave your comments. If you like this video, you are very welcome to subscribe to my channel for more videos in the future, okay? In the next video, we are going to deal with here, okay, the chain rule, which is the most important topic in Calculus 1. Don't forget to come back to this topic. Hope to see you the next time. Thank you, everyone. Have a nice day. Bye.